friends, in this video we are going to study about thermocouples. We will see its construction, its principle of working, then we will see its applications and advantages and disadvantages of thermocouples. So let us start with our topic. Thermocouples are the temperature transducers which are extensively used for the measurement of temperature variations. So thermocouples can be used for the measurement of the temperature, and it can also be used as a temperature transducer. Okay. Also thermocouples, they are a type of active transducers. Transducers, they are those devices which convert a non-electrical quantity into an electrical quantity. So here in the thermocouples, the non-electrical quantity, that is the temperature, it is converted into an electrical quantity, that is voltage. Now let's see the principle behind the working of the thermocouples. Thermocouples, they are composed of two metals. Two metals are joined with each other to form a junction. Okay, so there are two junctions between the metals. One is called the hot junction and the other is called the cold junction, or we can say that one is the measuring junction and other is the reference junction. So due to the two junctions of the thermocouples, they are kept at the different temperatures. So due to the change in the temperature of EMF, it is induced in the thermocouple, and the output voltage, it can be obtained with the help of the relationship between the voltage and the temperature. Now the working of this thermocouple, it is based on three principles, three effects: Thompson effect, Pettier effect and the Seebeck effect. So let's study these three effects. So as I have said that in the thermocouple, it is composed of two metals. At least two metals has to be present. These metals are joined together to form the junctions. There are two junctions. One is the hot junction and other is the cold junction. So these two junction, out of these two junction, one is connected to the unknown body, whose temperature we want to measure, and another junction is our reference junction, or we can say the known temperature, the junction which is kept at a known temperature. So this the body whose temperature which we want to measure, or the unknown temperature, that is called the hot junction, or we can say it is called the measuring junction. And the known temperature, the junction which is kept at a known temperature, it is called the reference or the cold junction. So therefore this thermocouple, it is going to measure the value of this unknown temperature by measuring it with the reference temperature. Okay, because we know the value, there are two junctions, one is known and one is unknown to us. So the value of the unknown will be measured with respect to the known temperature. So that is how the thermocouples, they work. Now this working principle, it is based on the three effects as I have said, the Seebeck effect, the Peltier effect and the Thompson's effect. So let's see these three types of effects. So let us first see the Seebeck effect. The Seebeck effect states that when two different or unlike metals, means when two dissimilar metals, they are joined together to form the two junctions, then an electromotive force or an EMF is generated at the two junctions. And the amount of the EMF generated, it is different for the different combinations of the metals. So whenever two dissimilar metals, they are joined together, suppose this is metal 1 and this is metal 2. So when two dissimilar metals, they are joined together to form the two junction, which are the hot and the cold junctions. So at these two junctions, the EMF is induced and EMF is generated at the two junctions. And if we are using different combinations of the metal, the amount of EMF generated will also be different. So that is the Seebeck effect. Second effect is the Peltier effect. The Peltier effect states that when two dissimilar metals, they are joined together to form two junctions, EMF is generated within the circuit due to the different temperatures of the two junctions of the circuit. So in the Seebeck effect, it was said that when two metals, dissimilar metals, they are joined that to form the two junctions, at these two junctions EMF is generated. But what is the cause of this EMF generation? That was not explained in Seebeck effect. That is explained in Peltier, that this EMF is generated due to the different temperatures of the two junctions of the circuit. That is why in the thermocouples where we were having the two junctions, one is called the hot junction and one is called the cold junction, because we are having the different temperatures at the two junctions. Okay. Now next effect is the Thompson's effect. So the Thompson effect, it states that when two unlike metals they are joined together to form the two junctions, the potential excess within the circuit due to temperature gradient is along the entire length of the conductors within the circuit. Okay. So the Thompson effect also says that the potential difference, the EMF which is generated in the circuit, that EMF generation within the circuit which is due to the temperature difference, that is along the entire length of the conductor, means at every point of the conductor, if we do the measurement, we will found that temperature difference and that potential to be present over that. Okay. Now the potential which is generated due to this Thompson effect, the EMF, it is very small in amount. That is why this Thompson effect, it is generally neglected for the proper selection of the metals in the construction of thermocouples. Generally, the Peltier effect, it plays the most important role in the working of the thermocouple, that when two dissimilar metals, they are joined to form the two junctions, and different temperatures are applied at the junctions, then EMF is generated. Okay. Now let's see that how the thermocouple, it is using these three effects for the measurement of the temperature. So this is the general circuit of the thermocouple, where we are having two dissimilar metal wires, metal A and metal B. These are joined together to form the two junctions P and Q. One junction is called the measuring junction, that is the hot junction, and another junction is called the reference junction or the cold junction. Now when these junctions, they are kept at different temperatures, like cold junction, it is generally kept at like 0 degrees Celsius, and measuring junction is kept at the unknown temperature which we want to measure. So due to these two different temperatures at the two junctions, EMF will be generated, and that EMF can be measured with the help of the voltmeter connected here. So thermocouple, it is going to measure the voltage which is generated between the two junctions, and we can see that this voltage, it is a function of the temperature difference between the two junctions. Now if the temperature of both the junction, it is made equal, then same EMF will be generated. Okay, so the net current flowing in the circuit, it will be zero. Okay. Now when the junction it is maintained at different temperatures, the EMFs will be generated different and the current flowing through the circuit will not be zero. Okay, so in this way the total EMF which is flowing through the circuit, it depends upon the metals which we are using for the construction of the thermocouple and also the temperature of the two junctions. Okay, so in this way the thermocouple it is used for the measurement of the temperature by measuring the voltage. Okay, so also this is used as a transducer because it is converting the non-electrical quantity temperature into an electrical quantity, that is the voltage. Now, as I have said that the voltage is generated in the thermocouple, and this voltage is proportional to the temperature difference of the two junctions. So let's see the mathematical relationship between the voltage and the temperature in the thermocouple. So the EMF which is produced in the thermocouple, it is given by the relationship E equals to A del theta plus B del theta square. Now here del theta, it is the difference in the temperature between the two junctions, reference and the measuring junction, and A and B, these are the constants. Generally A is very large as compared to B, so this can be approximated by the equation E equals to A del theta, or we can say that the change in the temperature is equals to E by A. Okay, so from this relationship you can see that the change in the temperature or the difference in the temperature at the two junction, it is proportional to the EMF generated in the thermocouple. So if the temperature difference is more EMF will be generated, and also this constant, it depends upon the materials which we are using for the construction of the thermocouples. So in the thermocouple temperature measuring circuit, the EMF which is set up, it is measured by sending a current through a moving coil instrument, and the deflection in this moving coil instrument is directly proportional to the EMF. Now EMF, it is a function of the temperature difference. So the moving coil instrument, it is directly calibrated to read the temperature difference, that is del theta. So here, if we see this diagram here, we are using a moving coil instrument here, which is like here we can use a voltmeter. So this change in the EMF, this EMF generated, it is going to produce a current. Okay, this can be measured with the help of the voltmeter also, and through a moving coil instrument also, in which the current is going to produce the deflection, and that deflection is directly proportional to the EMF generated, and EMF is a function of the temperature difference. So directly with the help of this indicating device, we can measure the temperature difference or the temperature variations. So in this way, the thermocouple, it can be used for the measurement of the temperature. Now in this thermocouple, as I've said that we are having two junctions, reference and the measuring junction. The reference junction is called the cold junction and the measuring junction is called the hot junctions. So this reference junction, it is usually 0 degrees Celsius. So directly the temperature difference will be indicated over the indicating device. Now thermocouples, the range of the temperature which can be measured with the help of the thermocouples, they are used for temperature measurements up to 1400 degree Celsius. So the metals which are used for the construction of the thermocouples, they should always produce a linear rise in the EMF, so that the equation E naught equals to A del theta, it can be used. Okay, so that the other constant B, it can be neglected. So there is only the linear relationship between the temperature difference and the output voltage, and the quadratic term, it will be neglected. Now let's see the diagram for a thermocouple in which the iron and the constantan, these metals are used for the construction of the thermocouple, and a moving coil instrument is used as the indicating device. So here the two metals which are used to form the thermocouple are the iron and the constantan, and we are having the two junctions. So here we are having a temperature control junction box, so that the temperature of both the junctions can be controlled. Okay, and then we are having a moving coil instrument which is showing the voltage generated at the two junctions. Okay, so directly we can get the value of the temperature difference over this moving coil instrument if it is calibrated accordingly to that. Now there are different combinations of the metals which can be used for the construction of the thermocouples, like one is the iron constantan, other is the chromyl and the constantan. Chromyl and alumyl. Rhodium and iridium. Tungsten and rhodium and copper constantan. So different combinations of metals can be used for the construction of thermocouple, and they will produce different amount of EMF. Okay. Now as I've said that to get a linear relationship between the EMF generated and the temperature difference, it should be there that the B constant, it should be very small, it can be neglected. and there is also only the linear relationship. The quadratic relationship should be neglected. Okay, so in that way the metals have to be chosen for the construction of the thermocouples. Also, the metals, they are chosen depending upon the temperature range which we want to measure. And also the kind of atmosphere. So these are the factors which affect the choice of the metals which are used for the construction of the thermocouple. Now here, this point should also be kept in mind that the thermocouples, they are a type of active transducers. Active transducers are those transducers which do not require an auxiliary power source for their operation. So, thermocouples, they are a type of active transducer because they do not require any auxiliary source. The power which is required for their operation, it is provided by the instrument, by the thermocouple itself, because here we are having the output voltage which is generated. Okay, so these are a type of active transducer, whereas the other temperature transducers like the RTDs and the thermistors, they are the passive transducers. But thermocouple, it is an active transducer, or we can say that it is a self-generating transducer. Now let us see some of the advantages and disadvantages of the thermocouples. The thermocouple, it has the ability to follow the temperature changes with a very small time lag. So it can be used in the applications where the rapid changes in the temperature are taking place. So thermocouple is going to quickly respond towards those temperature changes. Thermocouples, they are very convenient for the measuring the temperature at one particular point in a piece of apparatus. We are having a device or a circuit is there, and at one point we want to measure the temperature. So the thermocouples, they can work in those applications very conveniently. They can measure the temperature difference. So these are the advantages of the thermocouples. If we talk about disadvantage, the disadvantage of thermocouple is that they are having very low accuracy. So thermocouples cannot be used for the measurements where precision is required, where we require very high precision values, because it gives a very low accurate measurements. Also, the thermocouples, they should be protected against any type of contamination or the stray magnetic and electric fields, and to the environmental factors, it has to be protected so that it can have a very long operating life. Also, the thermocouples, they are placed at remote locations from the measuring devices. So measuring devices at some place, and at a remote location the thermocouples are placed. So a long connecting wires or extension wires are needed for the connection between the measuring device and the thermocouples. So that is also a disadvantage of the thermocouple. So in this video, we studied about the temperature transducer, which is used for the measurement of temperature, known as the thermocouple. We studied its principle of working, its construction. Then we saw the materials which are used for the construction of thermocouples, and then its advantages and disadvantages along with its applications. So I hope that this topic is now clear to you. Thank you.